Hello friends, today we shall continue our topic of Fourier transform. In the earlier lecture, we have solved some numericals on the Fourier integral theorem. We have also solved examples on Fourier cosine integral theorem. Now in this lecture, we are going to solve some examples based on Fourier transform, inverse Fourier transform and Fourier sine transform and Fourier cosine transform. So let me revise quickly the formula for the Fourier transform of f of x. Fourier transform of f of x is equal to under root of 1 upon 2 pi integral minus infinity to infinity the function f of x multiplied by e raised to power I s x dx. That is how we obtain the Fourier transform of f of x. It is denoted by f of s. Now inverse of this f of s, inverse of Fourier inverse of f of s is equal to root of 1 upon 2 pi integral minus infinity to infinity f of s, this function multiplied by e raised to power minus I s x ds. So basic formulae of Fourier transform of f of x and inverse Fourier transform of f of s. Subject to these two formulae, we shall solve some example. So I have already written the example of obtain the Fourier transform of this function. Which function? The function given. Let me switch. Given f of x, it is equal to 1. When it is 1, when mod of x is less than or equal to 1 and it is 0 otherwise. Mod of x is less than or equal to 1 means it is the closed interval minus 1 to 1. And mod of x greater than 1 means the interval which is complement of this interval, which is the interval minus 1 to minus infinity to 0 and from 0 to plus infinity. Minus infinity to minus 1 and from 1 to infinity. This should be omitted. Minus infinity to minus 1 and from 1 to infinity. That is the interval mod of x greater than 1. So for this particular function, we would be obtain the Fourier transform of this function. We know that. What we know? Fourier transform of f of x is equal to 1 upon square root of 1 upon 2 pi minus infinity to infinity f of x into e raised to power I s x dx. So subject to the domain of definition of this given function, we shall split this limit minus infinity to infinity as minus infinity to minus 1, then minus 1 to 1, and then from 1 to infinity, 3 intervals. minus infinity to minus 1, and from minus 1 to 1, and from 1 to infinity. Minus 1, minus infinity to minus 1, it is 0, and from 1 to infinity it is also 0. So it reduces to root of 1 upon 2 pi integral minus 1 to 1. In this interval minus 1 to 1, function takes the value 1, e raised to power I sx dx. It reduces to very simplest integral of the exponential function. So this is further equal to root of 1 upon 2 pi times integral of e raised to power I sx with respect to x is e raised to power I sx upon is. Limits are from minus 1 to 1. So let me employ the limits. 1 upon 2 pi square root of this. 1 upon is is independent of x. Now for upper limit x equal to 1, it is e raised to power is minus e raised to power minus is. That is further equal to root of 1 upon 2 pi times 1 upon is, and value of this is e raised to power I theta minus e raised to power minus I theta. It is equal to twice I sin theta. So this is twice I sin s. So I gets cancelled, and 2 upon root 2 is root 2. Root 2 upon pi sin s upon s. So that is the Fourier transform of the given defined function. Now this is the only first part of the solution of this given example. We want to evaluate this integral also. This integral is with respect to s, note this. And that integral with respect to s is involved in the inverse Fourier transform formula. इसलिए ये कैलकुलेट करने के लिए हमको इनवर्स फोरियर ट्रांसफॉर्म का फॉर्मूला लगाना पड़ेगा. वी नो दैट. नेक्स्ट, we know that Fourier transform, inverse Fourier transform, we get f of x. Let me mention this by inverse Fourier transform f of x is equal to root of 1 upon 2 pi integral minus infinity to infinity. This function f of s into e raised to power minus isx ds. As this inverse formula involves this integral with respect to s, I have used this formula deliberately. यहां पर भी with respect to s कैलकुलेट करना. अभी f of s की वैल्यू क्या है? So f of x is, therefore f of x is root of 1 upon 2 pi integral minus infinity to infinity. Now I am substituting the value of f of s, which is 2 upon root of 2 upon pi sin of s upon s into this e to the power minus is x ds, which is further equal to root to goes 1 upon root pi into 1 upon root pi becomes 1 upon pi integral minus infinity to infinity sin of s by s into e raised to power minus I s x को मैं उसको मैं ऐसा सब्स्टिट्यूट कर दो, कॉस ऑफ एस एक्स माइनस आई टाइम्स साइन एस एक्स और फिर ये ds. नोट दिस स्टेप, e रेज टू पावर माइनस आई एस एक्स की वैल्यू क्या होती है, e रेज टू पावर माइनस आई थीटा की वैल्यू कॉस थीटा माइनस आई साइन थीटा. वो फॉर्मूला यूलर्स फॉर्मूला मैंने यूज किया हूं. अब इसको दो डिफरेंट इंटीग्रल्स में स्प्लिट किया तो 1 अपॉन पाई इंटीग्रल माइनस इंफिनिटी टू इंफिनिटी साइन एस कॉस एस एक्स अपॉन एस ds माइनस आई टाइम्स 1 अपॉन पाई इंटीग्रल माइनस इंफिनिटी टू इंफिनिटी साइन एस एक्स अपॉन एस ऑफ कोर्स ds. बोथ आर इंटीग्रेटेड विथ रिस्पेक्ट टू s. अब ये साइन फंक्शन इट इज ऑड फंक्शन ऑफ s. ये ऑड फंक्शन है, डिनोमिनेटर का s वो भी ऑड फंक्शन है, सो ऑड अपॉन ऑड बिकम्स इवन. कोसाइन फंक्शन इज एन इवन फंक्शन. यानी ये जो पहली टर्म है, इंटीग्रेंड है पहली टर्म का माइनस इंफिनिटी टू इंफिनिटी, क्रॉस लिमिट से माइनस a टू a टाइप की, और फंक्शन इवन है. यहां पर ये फंक्शन ऑड है, ये भी फंक्शन ऑड है, डिनोमिनेटर का भी फंक्शन ऑड है, तीनों फंक्शन ऑड है, इसलिए राइट हैंड साइड टर्म का इंटीग्रेंड का फंक्शन ऑड है, इसलिए इसका इंटीग्रल माइनस इंफिनिटी टू इंफिनिटी 0 होता है, और इसका इंटीग्रल 2 टाइम्स 0 टू इंफिनिटी हो जाएगा. सिंस I should mentioning sin s cos sx upon s is even, and ये फंक्शन sin sx upon s is odd. So we have this becomes 2 times 2 upon pi integral 0 to infinity sin s cos sx upon s ds. इसकी वैल्यू 0 हो गई. अच्छा, ये किसकी वैल्यू है? दिस इज f of x. लेफ्ट हैंड साइड में f of x लिखा हुआ है, ये f of x by inversion formula. Now what is फंक्शन f of s गिवन टू अस? इट इज इक्वल टू, क्योंकि ये टर्म हमारी आ गई, साइन यहां पर a चाहिए, a नहीं चाहिए, साइन s cos sx, साइन s cos sx अपॉन s ds, ये टर्म वी हैव जनरेटेड. सो f of x कैसे डिफाइंड है? इट इज इक्वल टू 1. When mod of x is less than or equal to 1, it is 0. When mod of x is greater than 1. Therefore, ये इंटीग्रल की वैल्यू क्या होगी? इंटीग्रल 0 to infinity sin s cos sx upon s ds is equal to, ये पाई बाई 2 इधर चले जाएगा, पाई डिनोमिनेटर का न्यूमरेटर में जाएगा, 2 न्यूमरेटर का डिनोमिनेटर में जाएगा, इनटू f of x. अब f of x की वैल्यू सब्स्टिट्यूट कर दो, पाई बाई 2 इंटू f of x की वैल्यू कितनी है? 1. किस डोमेन के लिए, किस इंटरवल के लिए? मॉड ऑफ x इज लेस देन 1. पाई बाई 2 इंटू 0 किस इंटरवल के लिए? मॉड ऑफ x इज ग्रेटर देन 1. द फंक्शन इज डिसकंटिन्यूअस एट x इक्वल टू 1, क्योंकि यहां पर फंक्शन ये x इक्वल टू 1 के लिए डिसकंटिन्यूअस है. इसकी लेफ्ट हैंड वैल्यू है, लेफ्ट हैंड लिमिट है π/2 और राइट हैंड लिमिट है 0। दोनों लेफ्ट हैंड राइट हैंड लिमिट अनइक्वल है, इसलिए डिसकंटिन्यूअस एट x इक्वल टू 1। इसलिए एट x इक्वल टू 1, नोट दिस, ये फंक्शन की वैल्यू होंगी ये दोनों की एवरेज वैल्यू 1/2 टाइम्स ये वैल्यू π/2 प्लस लेफ्ट हैंड वैल्यू प्लस राइट हैंड वैल्यू, दैट इज π/4. So that is the value of this integral for these three different domains. So that is how we solve such type of examples. One more example we shall see. Second example of Fourier transform of f of t is equal to e to the power minus a into mod of t, a strictly positive. Earlier the function in the first example it was given as a function of x, ये example में function of t दिया। Fourier ट्रांसफॉर्म का फॉर्मूले डेफिनेट इंटीग्रल में है, इसलिए ये वेरिएबल्स डमी है। इट मे बी गिवन इन टर्म्स ऑफ x, it may be given in terms of t, it may be given in terms of u, whatever variable, so don't confuse this. ये फंक्शन का फोरियर ट्रांसफॉर्म, फोरियर ट्रांसफॉर्म की डेफिनेशन क्या है? f of s is equal to root of 1 upon pi 2 pi integral minus infinity to infinity. Function is given in terms of t, f of t into e raised to power ist d given. Yes, this we know that. WKT means we know that, short form acronym of that, we know that. Given, what is given to us? F of t is equal to e to the power minus a times mod of t. See here, when t is negative, mod of t is equal to minus t. ये mod of t की वैल्यू minus t हो जाती है कब? When t is negative. t is negative. Mod of t is minus t. So ये minus t into minus a plus at हो गया. When t is greater than or equal to 0, mod of t is equal to plus t. So it is equal to e to the power minus at. So when t is negative, ये function की value e raised to power plus at. When function is non-negative, greater than or equal to 0, then its value is e to the power minus at. तो इसको हम split कर देंगे. f of s is equal to root of 1 upon 2 pi limit from minus infinity to 0, minus infinity to 0 की वैल्यू क्या है फंक्शन की f of t की? e to the power at into e to the power ist into dt plus minus infinity to 0 or 0 to infinity. From 0 to infinity, from 0 and onwards, function takes value e to the power minus at into e to the power ist into dt. 1 upon 2 pi is common throughout. So, should note this. 1 upon 2 pi under root of this times integral minus infinity to 0, taking out t common, e to the power a plus is times t dt plus this integral 0 to infinity. Now take out minus t common, e to the power minus t. So minus t common is a minus is times t into dt. Now integrate them with respect to t. Root of 1 upon 2 pi times e to the power a plus is upon a plus is. This is the first integral value for the limits e to the power minus infinity to 0. This is mine plus integral of this e to the power minus times a minus is times t upon minus a minus is. Here limits are from 0 to infinity. So that is further equal to root of 1 upon 2 pi. Now I shall employ the limits of the first integral. Here it should be t. When t is 0, e to the power 0 is 1. 1 upon a plus is minus e to the power minus infinity is 0 minus the value of second integral. Again e to the power minus infinity is 0 for the lower limit. E to the power 0 is 1. 1 upon minus e minus is. So that is equal to root of 1 upon 2 pi times 1 upon a plus is minus 1 upon a minus is. There are three negative signs, so it is negative. Let us simplify this. Times a minus is minus a minus is upon a square minus I square s square. A plus ib, a minus ib is a square plus b square. So it is here a square plus s square. So 1 upon 2 pi times, here a cancels, minus 2is upon a square plus s square, because minus I square is equal to plus 1. That is the Fourier transform of this function. F of t is equal to e to the power minus a times mod of t. Now, third example. Obtain Fourier sine and Fourier cosine transform of e to the power minus mx. The function given is in terms of x, number one. It is e to the power minus mx. Mx is strictly positive. If it is m is 0, it would be 1 perhaps, and if it is negative, the exponent would be positive. So m is necessarily greater than 0. Now, Fourier sine और कोसाइन के फॉर्मूला, फोरियर साइन ट्रांसफॉर्म का फॉर्मूला क्या है? फोरियर साइन ट्रांसफॉर्म को हम एफ एस ऑफ एस से डिनोट करते हैं, जिसका फॉर्मूला ये है रूट ऑफ 2/पाई इंटीग्रल 0 to infinity f of x into sin of sx dx. यदि फंक्शन f of x है तो उसको sin of sx dx हो जाएगा. फंक्शन थीटा है, f of थीटा sin s थीटा d थीटा हो जाएगा. लाइकवाइज मस्ट ये फोरियर साइन ट्रांसफॉर्म का फॉर्मूला है. फोरियर कोसाइन ट्रांसफॉर्म का फॉर्मूला एफ एस ऑफ एस रूट ऑफ 2/पाई इंटीग्रल 0 to infinity एफ एस f of x into cos of sx dx. sin sx की जगह cos sx. Formula, rest of the terms they are similar. Very simple. The simplest perhaps. Given. What is given to us? F of x is e to the power minus mx. M is positive. Fourier sine transform of f of s is equal to 2/pi integral 0 to infinity f of x into sin of sx dx. So that is equal to root of 2/pi इंटीग्रल 0 to infinity. ये फंक्शन की वैल्यू सब्स्टिट्यूट कर देंगे e to the power minus mx into sin of sx dx. यहां पर फिर वही फॉर्मूला हम बार बार यूज करते हैं. इंटीग्रल e to the power ax into sin bx dx is equal to e to the power ax upon a square plus b square times a sin bx minus b cos bx. नोट दिस. तो यही फॉर्मूला हम यहां पर लगाएंगे. रूट ऑफ 2/पाई e to the power minus mx upon m square plus s square upon into minus m sin sx minus s cos sx. Limits are of course from 0 to infinity. Root of 2/pi times. For upper limit x equal to infinity, e to the power minus infinity is 0. 0 into anything is 0. Minus. Now employ lower limit. E to the power 0 is 1 upon m square plus s square. M square plus s square into minus m. Now lower limit x equal to 0, sin 0 is 0, minus s, cos 0 is 1. inner bracket, outer bracket. So this minus and this minus becomes plus. So root of 2 upon pi times s upon s square plus m square. This is the Fourier sine transform. Similarly, Fourier cosine transform is equal to root of 2 upon pi integral 0 to infinity e to the power minus mx into cos of sx dx. That is further equal to e to the power minus mx upon m square plus s square times minus m cos sx plus s sin sx. Limits are from 0 to infinity. For upper limit x equal to infinity, it is 0, e to the power minus infinity is 0, minus. For lower limit, e to the power 0 is 1 upon m square plus s square times minus m cos of 0 is 1 plus s into sin 0 is 0. So minus into minus, it is plus m upon m square plus s square. This is Fourier cosine transform of e to the power minus mx. This is Fourier sine transform of e to the power minus mx. So that is how we determine the Fourier transforms, evaluates given integral, deduction, deduced integral with respect to s by inverse Fourier transform, as we have seen in the very first example today. In this third example, we have seen how to employ the formulae of Fourier sine transform and Fourier cosine transform. So with this, I shall stop here. Thank you very much, my dear students. Thank you.